Okay, I just want to give this one a try. I know we kind of reached some sort of agreement, but I want to show this example with the graphing now that I figured out how to get Desmos to do piecewise functions. Okay, so we have this this piecewise function here. And we want to look at each of these limits. So we want to look at what's happening as it's getting close to -5 and 2. Each of these pieces is a continuous function. Two linears and a quadratic, those are continuous, so all the points are there. So any points of discontinuity will happen at the boundaries of the pieces. And so let's take a look at what those pieces look like on the graph. So I've graphed it here. So when x is strictly less than -5, our function is 10 minus x, which is this part here. When we get to -5, it's not the function, the piece we're going to use then from -5 until 2 is going to be the function y equals x. So that's going to be this little piece here. And then as soon as x is greater than or equal to 2, our function is going to be this sort of half parabola or portion of a parabola, x minus 2 all squared. So that's what this part is here. Okay, so let's take a look at what's happening at -5. So coming from the left, we look at the limit as x goes to -5, and we put this little negative. That means coming from the left of this function. So which piece are we using? Well, x less than -5, so we're coming to -5 from the left, so we're going to use this function here, or this part of the function, again, 10 minus x. And we want to know, what are we getting close to? Well, that's what's nice about Desmos. We can actually click on here and watch what happens. We're now at x equals negative 11.75. We're at 21, and watch as we get closer to x equals, where should I point it so you're not going to see it? X gets closer to -5. Notice, so at -10 it's about 20. As we're getting closer to -5, our y value keeps coming down. Looks like it's getting closer, about 15, right? So we're getting closer and closer to 15. Now, if we go too far, we jump down to the other piece. We don't want to do that. We want to keep coming from the left. And so sort of the limit as we get there, as we get really close, we're getting really close to 15. There we go, -5.03. We're at 15.03. So what we can say is that when and again, if you plug in -5 here, you get 10 plus 5, which is 15. So then we can say that this value, the limit, is the number 15. Okay. We then want to check what's happening from the right. And again, for that we look at the limit as x goes to -5, but this time we're going to come from the right side. So as we're coming from the right side, we're getting close to -5 from numbers that are larger than -5. So that's this interval here. So we're going to use y equals x as our function. And what we're going to do is come back here. So on y equals x, we're going to move our point. We're going to get closer and closer to -5 from the right-hand side. And notice as we do that, -4.4 is at -4.4. And as you know, -4.86 is at -4.86. As we get closer and closer, and actually -5 is at -5. That isn't a function value, because as we see up here, -5 is less than or equal to x. So there is an actual value there, but what we want to, when we think of the limit, it's not when we're at the point, it's as we get close to it. So we still say we're getting closer and closer to -5. So this limit is -5. And then this is the two-sided limit. Which compares the left and the right. So this is just as x goes to -5. It doesn't have any indicator, so it's coming from the left and the right. What we have to do is compare these two. Does 15 equal -5? Question mark. No, it doesn't. It's not equal, so the limit does not exist. For there to be a limit, a two-sided limit, both the left and the right have to be equal. Okay. We also see that this is a point where the function, where the piecewise function is discontinuous. There's this big gap. That's discontinuous. We have to jump down here. Now, the thing is the function value itself actually does exist. We're using this piece, -5, -5. Notice you go to try to go to -5 up here, you can't, because it's not part, it jumps down there, okay? Because -5 is not included in that first part of the function. So even though the question did not ask it, if we were asked what is f of 5, or sorry, -5, we would plug it into the function y equals x. So then we get y equals -5. -5 is our function value. Notice there is no limit there. So we do have a function value at -5. It is -5. We have a left limit at -5, which is 15. We have a right limit at -5, which is -5. But we do not have a two-sided limit at -5. It does not exist because the left and the right are not equal. Okay, and this is a discontinuous. A point of discontinuity. And again, we see that on the graph somewhere. Here we go. We'll do the same thing. You can do the same thing looking at what's going to happen at 2. We can see here the picture. It is discontinuous. There is a jump. There's a hole. Yeah, you just see there's a gap. Okay, we'll call it the gap. But as we come back and try to answer this second series of questions, basically the same thing, except what we're going to do now. Let me just show that we do the same thing. What we're going to do is we're going to change the number we're going to. We do the same process. We look at the left and the right, just like, you're crossing the street, always look to the left and the right. If you're in Thailand, you look to the right and then the left, but or England, whenever they drive on the right-hand side. So we're not going to worry about this. We're going to look at what's going to happen. Same sort of analysis. I'll take all this stuff out because it might be different. Okay, so now let's go ahead and do it in red. We're going to look at the limit as we go to the x equals 2. We're going to go from the left, and we're going to go from the right. We're going to see what these are, and then we're going to see if there is a two-sided limit going to 2. We'll also look if there's a function value at 2. So again, going from the left, we come down, and so from the left, we're on this piece of the function. As we go, and as you see, as we get closer and closer to x equals 2, we're getting closer to y equals 2 as well. Now, it jumps down there. We again, with limit, we don't actually get there, but let's see how close I can get it. It's about 1.99. My mouse is not, there we go, 1.95. I'll call that good enough. We're getting very, very close to the y value of 2. Okay. So we put that. So the limit as x goes to 2 from the left is going to be 2. So we come from the right, what we'll see is that coming from the right, we're on the third part of the function. So notice our x value is getting closer to 2. What's the y value getting close to? Well, it's getting closer to looks like 0. Okay, so we get closer and closer and closer to 2. We're getting closer to 0. Now we don't want to actually, again, limits, we don't want to look at what happens actually at 2, although that is a function value. We'll see that that function value is on the third part of the function. But we want to see what happens as we get very, very close. And my mouse is, there we go, 2.2, we're at 0.4. So we can see as we get closer to x equals to 2, y is going to be 0. Oops, not that one. Come back here. So from the right, we're going to 0. A two-sided, we look at the left and the right. Is 2 equal to 0? I don't think so. So this does not exist. This limit does not exist because the two sides do not equal. However, and so yes, definitely it's discontinuous because you could kind of see that. Now there is a function value, f of 2 does equal 2. Because there is this part, you could numerically plug in 2 here. 2 minus 2 is 0. 0 squared is still 0. Okay, that's the right. This is the actual function value. But notice both of these are discontinuous. Now, before we leave this one, I want to empower this a little bit more to show us sort of the light that went on. Is I'm going to change this function. I'm going to add 2. I'm going to add a plus 2 to this, which will move the third function up by 2 and make it so that it's actually a continuous function at this point, and we'll see what happens. So I'm going to turn this one off, turn this new one on, and I just to show you what I did is on this last function, I took this, what we had, I added 2, which is a vertical shift upwards. And now look at this. They are connected. It is no longer discontinuous at 2. And notice this. This one has a left limit of 2. This has a right limit also of 2. As x comes to 2, it's equal to 2. And it also has a function value of 2. So let me write this on the new piecewise. I'll kind of come down here. The only part I want to examine is we looked at y equals x minus 2 squared plus 2 as our pieces. Okay, this was our y2 and this was our y3. So then with these in mind, we had a limit as x goes to positive 2 from the left. Use our notation. That was equal to positive 2. We found that the limit as x goes to 2 from the right, that was also equal to 2. Again, looking at that visual, because we moved this thing up, right? So we did have a two-sided limit. So this was left, this was right, and this is our two-sided. And so that we write that as the limit as x goes to just 2 with no little indicator on the left or the right. That's also equal to 2. Additionally, the function value at 2 equals 2. Since all of these puppies are equal, everything's equal, this is a continuous doesn't look right, but maybe it is. Help me with my spelling. Okay, and you can kind of see from the graph. So there's that part. Really, when we study math, we need they call it the rule of 4. Graphical, so you can see visually. So that's one way of learning. Numerical, and we have both of those. We have the graphical. Here's the numerical. We actually look at the numbers, what's happening as we come through, and watch. See, we get a nice continuous flow to our graph. On this part, no continuity. Boom, it's a jump Ouch, that hurt. Um, so that's not continuous. This is continuous. To be continuous, left and right limits have to be equal. That gives us a two-sided limit that gives us a value. The function value also has to be equal. Boom, we've got continuity. If any one of those four things is not equal, is something different, then we get discontinuous because we gotta jump there. So those different things coming together, limits with continuity versus discontinuity, I think it's coming together, and hopefully it's making a lot more sense to me as we try to work through and explain this. And that's really what education's about, is these discussions we get to have. So thank you. Hopefully this was helpful. Try a few more, but that helps the difference. So we see this continuous here, and then when I look at the other one, I can see it's discontinuous, and as I try to do it, I see this drop, boom, boom. That's discontinuity. And we saw what happened because left and right are not equal. And there was a function value, but left and right were not equal, so it's discontinuous. All right. Keep up the good progress. Hope it all works well. Thanks.